we can go ahead and get things started. So thank you everyone for being here with us tonight or this morning or whatever time it is where you are. I really appreciate all of you making time in this crazy time that we're all in to join us. Just a little bit about what this open house is really intended to be. We are going to do a quick run through of what we do at FieldKit, just to kind of orient everyone, get you feeling like, okay, you have a sense of what it is that we do if you're not already aware. And then we're going to have a live demo of the hardware and the software. And then we really want to open the floor to any questions, thoughts, input from all of you. One of the reasons why we've been hosting these open houses is ultimately we want our everything that we do to be a reflection of the people that we are working with and the community that we're creating for. So, you know, any questions and input and thoughts and feedback and polite criticism that you have is not only welcome, but is strongly desired. So with that, so what is FieldKit? It is scientific grade open environmental sensing for everyone. So what we've created is an open source and modular software and hardware platform that really allows everyone, no matter what their background is or technical expertise, to collect and share you know, field-based research data and to tell stories with that data through a visual platform, as well as to connect with other people around the world around the things that they're learning. And FieldKit is we're a project of Conservify, which is a conservation-focused not-for-profit. We always like to underline that we're a not-for-profit because ultimately that is what's driving us, is that desire to make these tools accessible and ultimately make the world a better place. So the folks who'll be talking to you tonight, so we can go through from left to right if we want to introduce ourselves really quickly. So Shah.
Yeah, hi everyone. My name is Shah Selby. I know a few of you on this call today. I mentioned in the chat that I work a lot with open source hardware. So how do we create tools that other people can build on and kind of take ownership over to and create their own versions of stuff? And so that's the end goal of FieldKit, is trying to reduce the cost and complexity around environmental monitoring, making use of kind of the most cutting edge tools we have today. So I'm going to talk a little bit more as I do the demo later on. So thanks for all joining.
Yeah, hey everybody, I'm Jer. I started this project with Shah a really long time ago. Well, not that long ago, but in 2013. And yeah, I just wanted to say how great it is to hear lots of people from all around the world joining us. And one of the things you're going to hear later is that a big reason we started this project was to try to make environmental sensing more accessible to everybody all around the world. And we've always had a focus for FieldKit not to be something that's centered in North America. So it's great to see everybody here.
And y'all have already heard from me. I'm Lindsay Stark. I'm the community manager at FieldKit, which basically means my job is to listen to people and to facilitate interactions and to ultimately ensure that, you know, both information and experience aren't siloed in one area, whether it's area of expertise, region of the world, et cetera, et cetera.
I'm Pete Marchetto. My official title is Research Engineer and Instrumentation Scientist, but I'm kind of the sensor guy. I handle kind of application side engineering work, where we're looking at which sorts of modalities need to be sensed to get the kind of data that you need, and all the way through to encoding data and getting it up online. So that's kind of where I live. But if you're looking for a sensor modality, I'm kind of the guy in-house who's tasked with looking at those.
Awesome. So we will all be here, keeping an eye on the chat, answering questions. Feel free to put questions in chat along the way if you'd like. And like I said, we'll also have the floor open, as it were, toward the end of the session. So as we said earlier, you know, our tagline is that FieldKit is for everyone. And what this means is that FieldKit is intended to be a high quality, low cost, open source, and non-proprietary environmental sensing solution that is accessible to everyone. And that encompasses not just the hardware and the software that we build, but also you know, our systems for data management and sharing, because ultimately we want to empower everyone, whether they are you know, educators in New Zealand or field scientists in India or citizen scientists in North America, all to be able to better understand their environment and advocate for it. So like I said, FieldKit really is more than just a tool. It is our open source tools, plus this data sharing platform and a community of environmental care that we are continually looking to build and nurture along the way. But from a technical standpoint, as I've said, we have sort of three main components. The FieldKit.org site, or the portal we'll often call it, which is where your data ultimately lives and where you can interact with it, comment on it, share it, etc. The app that serves as a way for you to interface with your station and pull data on and off. And then finally, the hardware, the FieldKit station itself. So first, to dig into the hardware, one of the things that's I think particularly noteworthy about FieldKit is that the hardware itself is completely modular. So the idea is that if you need a new tool for some new sensing problem, you don't need to buy a whole new station kit, something along those lines. You can swap in a sensor module into the FieldKit platform that you already have, and you can go with it. So it gives you some flexibility. And as we are, you know, we have, what is it, like six sensor modules right now available. We're building more. So, you know, as we continue to add these, the flexibility of the hardware itself increases. So here on the screen, you know, you can see the basics, the blue upper board, which is kind of the brains of the station. Underneath it, a lower board that serves as the communications module that helps to, you know, pass information from your station onto the software platforms and also manages the power. And then the module base, that's those four, I don't know what those are technically called, those four areas where you can put in a module to swap in and out.
Yeah, I think just one thing to note here is that just to get everybody thinking is that those modules can be taken in and out, and you don't really have to do any configuration with them. And then one thing that I also always want to mention is that they can be different or they can be the same. So you could have four of the same module. For example, let's say you wanted to do water temperature at different levels inside of an aquatic cave or something like that. You could have four temperature modules in there. So there's all kinds of different configurations that are available to you. And those configurations will get more as we develop more sensors, and we'll talk about that later.
All right, yeah, we'll dig into this during Shah's demo. So the next piece of the sort of FieldKit ecosystem is the app. So, you know, usual sort of app spiel. It is available on iOS and Android. I do always like to note that it is, free to download, free to maintain. We don't have like a software subscription model. And the app sort of serves as the basic interface for interacting with your station in a flexible and easy and accessible way, as well as gives you some sort of basic screens around deployment and data visualization. So you can see here in this first screen, that's basically the deployment screen that goes through where your stations are. The second deployment screen covers the walkthrough of getting set up. Third screen really is the summary of the deployment and the basic readings you're seeing here for a weather module for this particular station. And then finally, the sort of in-app data visualization component that shows, some changes over time. And the app also provides some onboarding, although there's other more in-depth onboarding on our site as well.
Yeah, just a note about that, in case you're wondering what the kind of deploy thing means. It's really just a demarcation for you to be able to say, like, this is when this sensor goes into its kind of real recording mode. So you might be testing it at home or doing kind of pre-configuration, and then as soon as you hit that deploy button, the scheduling that you put into place comes into action. So we have some pretty thorough scheduling available that you can get it to set up, every X minutes or every X hours. But then you can also do a little bit more in-depth scheduling like that as well on top of that. So that deploy is just a way to flag, hey, the sensor is really in action right now, so that you can see the difference between that data and the data that you might have been doing at home or in the lab.
Yeah, the other thing that deployment does is you have the opportunity to answer a lot of questions about where you're putting your sensor, why you're putting your sensor out there, and gather metadata that then gets attached to all the data that falls within that deployment range. And so that includes things like photos and audio recordings and other stuff that's just tied specifically to when you hit start on deployment and all the way until when you hit stop on deployment.
Awesome. And then the next piece of the puzzle, as we discussed, is our web platform or the portal, which you don't have to have a FieldKit station to join. You could sign up right now and go and look at the projects that are already in there. The portal is where you go to manage your projects, which can be a single station deployment or a multi-station deployment, depending on what you're doing, whether you're working within a larger team or you're working by yourself. And it serves as the place where you can really dig deep into the data and start to see those patterns around how things are changing over time, how things might interrelate. And additionally, there is the ability to comment on the data, annotate, do these sorts of more say full and round ways to interact with the data versus just seeing a graph there. We are adding in the ability to share data via Twitter or URL if you want to be able to share things out, and working on localizations. Everything is currently in English now, but we're working on translating everything that we have into Spanish, French, and Portuguese to get started with more languages along the way. Working with some of our community members to crowdsource some of that translation, as well as bringing some folks in as needed. Another thing that I always like to note when we're looking at this is that you own your data. Nothing in our model is about either holding your data sort of hostage or using it for our own purposes. You have the ability to make what you pull off your station completely private, or share it out to just your team members, or share it out to the world at large, depending on what you're doing and what your needs are there.
Yeah, sorry, go ahead, Jer.
Yeah, I just wanted to add a couple of things to this. First is just to sort of underline the idea of team management. So, lots of people who are doing projects in the field, it might involve you and some colleagues or some students or whoever, whatever that is. And so these projects facilitate that, so you can have a kind of place where people can come and discuss the data that you collected. And so this idea of social analysis of data is really core to what the platform does. So you can highlight a section of the data and kind of do the same type of commenting that you could expect to do on an Instagram post or something like that. And all of that can either be public or private, or it could be both. So there can be like private conversations within the team and then public conversations outside of it. And so it's really easy to sort of highlight a piece and then share that link with somebody either on your team or not on the team who can kind of jump in and talk about it. And I think that to me is one of the like kind of most exciting things that the platform does. And then we have lots of easy data views that you can view the data, but I wanted to underline the fact that our goal is to make the data, get it really easy for you to get the data in and out. So we want to make it very easy for you to export the data to whatever platforms you're already using. So yeah, it's never going to be a hassle for you to get your data out of the FieldKit.
Yeah, I'll also add that, while one of the things we're doing as a nonprofit organization is offering the ability for people to have us host their data if they'd like, but you can, even the web platform is fully open source. So you can spin up your own version of that and do whatever you want with that regard as well.
Thanks, guys. Another thing, sort of one of the more recent projects we've been working on in the platform is this concept of collections. So the idea is that anyone, whether they have a station, whether they're running a project, whoever they are, can curate collections of stations based on whatever criteria they're looking for. So that could be, you're running a project in a national park with 20 stations spread out across the park. That might be a collection, just as a student may decide to collate stations from various places around the world on a particular ecosystem or particular problem to see what that looks like in that bigger picture. So this is just another way for us to provide this ability to provide this social analysis of data and to make this something that has that collaborative and community element to it. And finally, not one of our proprietary things, but something that's really core to our mission is this community concept. And so we do have a community forum that is on single sign-on with our portal, where we allow anyone, again, whether they have a station, whether they are currently using it or just interested, to come and sign up and talk to both our team, but then also our growing base of users and enthusiasts, to discuss not just things like, oh, what's this particular thing mean in the data, but start talking about kind of bigger picture things, how to take the data and do things with it, and also to connect with others who have maybe similar pain points or challenges. Sort of serve as a place for us to all work together to build a better world. And so part of my spiel is I always tell everyone, you can sign up right now if you go to this URL, and I encourage you to. I'd love to see some of you in there, talking to the folks that we're building. It's a small forum, but it is growing. All right, and now I'm going to hand it over to Pete to talk about sensor modalities and resolutions.
But actually, before that, Lindsay, if you don't mind going back one slide, I just want to point something out about our community forum. One of the things that we do in our forum, actually, you'll see it in the background on that left side there. we actually highlight grant opportunities that are available both for people who are interested in our systems as well as those who aren't, because of the fact that we believe in trying to get conservation scientists to all move forward together. Lindsay and I especially are always combing through whatever we can get in from NSF, Fish and Wildlife, USDA, and then also private foundations, and posting usually on a weekly basis grant opportunities for small and large scale projects if anybody's interested in them. Yes, we do have a little bit of a vested interest in that, because if you get the money, then we can take some of it and make these products to give to you to help you do your work. But we're also very interested in just making certain that people have access to the funds that they need to do the projects that they want to. So just wanted to point that out.
Oh, I'm so glad you pointed that out, Pete. Thank you so much. Yeah, we're really trying to build it to be a resource that's useful for, anyone who's working even tangentially in this space.
And now I beep to advance the slide, right?
All right, yeah.
So we're trying to get our sensors to be on the same level as pretty much any other research grade, quote unquote, data logger system would be, but we're definitely trying to keep our price down relative to a lot of other folks. So the thing is that I wanted to go through with you and show you exactly what we're working with right now. What we have in the shop at present, and what we're actually releasing as production items, includes pH. We have a resolution of 0.1 for the pH, and the range is full. Conductivity, we're basically doing a superset of the usual conductivities that you'd see for freshwater, seawater, and then brackish brines. We could probably get up to dead sea or salt and sea levels easily, and we still wouldn't break the probe or have a problem measuring it. Dissolved oxygen, you would basically have to have a hyperoxygenated lake to go off of our range, and the resolution is significantly less than what you'd normally need to just see what the trends are. This is higher resolution than just seeing like what a fish tank's at. For contact temperature, which we usually use in our water kit, we have a 1000 ohm platinum RTD thermistor, and that basically just means that we have the same sort of sensors that pretty much everybody else who's doing high resolution temperature measurement does. We issued the old school thermocouple just because resolution on that is much worse. And then for distance, we are mainly looking at this as a way of gauging stage height for streams, lakes, etc. And this is an ultrasonic distance sensor with a resolution of 1 millimeter that we can use for stage measurement, but also if you have something that you just want to know the distance to, say for example, snowpack, that's also something that you could use that sensor for. Beep. Yes, it's old film strip habits die hard. Then for our weather system, we have 6 different modalities covered in there. We have wind speed, wind direction, rain depth, relative humidity, air temperature, and barometric pressure. And so all of these are within a resolution that's usually commensurate with, well, for wind direction, it's a little bit less resolution than you'd get out of like an NWS weather station here in the US, a National Weather Service monitoring station. But our wind speed at 0.1 meters per second, rain depth at 0.28 millimeters, it's a little bit weird, but it's multiple conversions that make it so that the resolution is 0.28 millimeters per tip of our tipping bucket rain gauge. That's also why that says NA for range, because you theoretically could have infinite rain going through, and the tipping bucket just goes back and forth, and we count how many times it switches. Relative humidity, air temperature, and barometric pressure, all completely standard values. And barometric pressure, just so that you know, we go down to 50 kPa and up to 110 kPa. Those are indeed absolute values. That's not gauge pressure. So, and with that, that's really where we are right now insofar as the modalities we have developed. And to see those modalities in action, I believe I'm handing it over to Shah for a demo.
Indeed. All right. Thank you so much, Pete.
Yeah, and before I go into the demo, I'm just going to talk a little bit about Pete's role. Pete's role here is to help us think through how we can take lower cost systems and really do the work that we need to do to make them, scientifically accurate and representative to kind of what's commercially out there. So we deeply believe at FieldKit that we can build systems that are much lower cost, but compete very very well against like the things that are out there right now. So I'm going to show you our hardware and go through a demo of how it all works. First, I'll talk a little bit about the data logging part of our hardware. So we intentionally broke it up into two different boards. The reasons why we did that was because we wanted to make the ability for FieldKit to be upgraded very easy. And so this top board that has the screen on it has our microcontroller. Right now we're running an ATSAMD51 microcontroller, but it also has like the SD card slot and all the memory and things like that. And we've separated out the charging circuitry and all the radios so that if you did want to create a FieldKit that used, some kind of obscure satellite radio for some reason, you could do that just by spinning up this bottom board. You don't have to actually change the entire architecture of the device. Or if your power charging circuitry changes, then you could do that, with just spinning up a different version of that board. Down the line, we're expecting to have a FieldKit that runs like a system on a chip, Linux kind of version of FieldKit, and that is just going to require just the spinning of this top board, and it'll still run off the bottom one. So that's kind of our architectural thoughts around why we did that sort of thing. I have sitting right next to me here one of our FieldKits, and so you could see what we did for most deployments was we created this configuration that has this module board with 4 different bays in it, and that allows you to kind of mix and match the sensor modules that you're using here. For this one, we just have a water temperature module on there, but we created this Pelican-like box that is water and weather protected to allow you to kind of change those certain configurations. It provides a friction fit housing for our battery, has a button, external button that turns on the Wi-Fi. And then you can see here the screen and all the rest of it. One of the things we do with FieldKit is we auto-generate names for these stations, and usually it's just the name of an animal plus an adjective. So this one's the rural Impala, but you could change those names to whatever you want, and that name corresponds to the kind of the Wi-Fi access point that these things create when you're when you want to connect to these things and download the data from them. So yeah, there's connectors on the top for the button for the battery and for solar charging. So you can plug in 12-volt panels on this. And then on the inside, we put just mounting holes on the inside of the lid. Here you see a clipboard attached to it, but it's created in the way that you can kind of attach a bigger battery pack or do all sorts of different stuff. And then right here on our cable plate, that's just an acrylic cut plate that you can mix and match and change the gland configurations or bulkhead connector configurations as you want. And there's room for a lock to kind of lock these systems once they're out in the field. The hardware itself connects through to our app, and so hold on, let me get this set up. So our app allows you to kind of connect to the station both through the access point, or you can create known Wi-Fi configurations for this. So you can have the station itself upload data to the app, and then you subsequently will upload it once you get within cell coverage or Wi-Fi network, and you can upload that data. Or you can have FieldKit as itself just upload directly through Wi-Fi network. And so here you could see that I'm connected to the FieldKit station in our app. That's why rural Impala is blue. There's 3 main screens, right? There's the station screen, there's the data screen, and this shows what data you've downloaded and uploaded to the system, and then there's a bunch of settings you can change for these things. If I were to click on rural Impala, you see kind of the detail, station detail right here, which shows what the current reading is. When you're connected to the station like this, it's actually taking readings at a much faster rate than what you configure it to take once you do the deployment. And then if you were to go into the data page, you can actually click on the little down arrow and download the data off the device itself. So here's, I'm saving, this one unit has taken 31,895 readings. And so let me just quickly end the deployment for this thing so I can go back through and show you what the deployment ends up looking like when we do this thing. So here's the station undeployed. If you were to click deploy, it gives you the option to name your location. So we can type in whatever we want to type here. And then you could do a data capture schedule every so many minutes, or you can do complex where you're taking a bunch of readings at sunrise and sunset and adding a bunch of different times and things like that. So usually for this, I'll just hit simple and I'll move forward. And in all of these field notes, you can add information about the deployment. Before you walk away from it, you could take a picture of the deployment. So here's taking a picture of it, sit next to me. And then you go through and hit continue. When you do that and hit record, it will actually deploy the station. And so now all the data that's being collected from this point forward has that metadata associated with it moving forward. Next, I'll show you guys the portal. So this is what the portal looks like. Here you'll see at the top, there's the projects that this demo account is a part of. And then there's community projects at the bottom where you can kind of see more. And to add a project, you just hit add project, and it allows you to set up all this information and create team members, make a project public or private so people can see it or they don't see it. But if we were to go into the FieldKit demo, you could see some of the details that you add are your goal and kind of where it is, what the duration of the project is. You can add team members. We have a section that shows you what sensor modules are part of this project. FieldKit itself interfaces with the native lands API, so it pulls in all that data around what the native land that this project is taking on is happening. And then there's a bunch of like admin sort of tasks, so you can add people and give them different permissions and do all that sort of stuff that is kind of fun to do. But if we were to look at rural Impala and we click explore data, that takes you to this data exploration page that shows you kind of all the data this is collected over time. And so if I just select the data ranges like this, just drag and drop, it zooms in and gives me what that data looks for that different time span. And the cool thing about the FieldKit portal is that every single one of these data views, no matter how you want to configure it. So say you want to look at this as a time series and you want to compare by adding that same time series, but looking at it, in a histogram, you could do that. And whatever this configuration that you change for this will become its own unique URL. So if you were to go down and write a comment about this, then that comment is tied to that specific data view. So I can show you if I were to kind of close out this comparison and zoom out so it's the full thing. If I click on this data view right here, wow, this is cool, it takes me back to the exact same data view that I saw. And the great thing about this is, those specific URLs become kind of captured data views that can then be shared on social media, or they can be kind of put as references in papers and things like that. So, we give the opportunity to do time series, histogram, range, and also map-based visualization. The map's not very interesting right now, but we do have some field kits that are in a moving configuration as opposed to kind of a static configuration. And in those situations, it will be a much more interesting thing to be able to see how your field kit's moving in space. And so we've got a bunch of those that are being tested now, but it's functionality that we have that we have currently. So that's a quick demo. I'll leave it at that, and we can kind of continue the conversation. If you have any questions about it, just let me know.
All right, thank you so much, Shaw. So we just have a couple more things, and then we can segue into the discussion portion of this event. So back Earth Day of last year, we ran a giveaway for 50 lucky folks from around the world to be able to win either a FieldKit weather or FieldKit water station. We had something like 150 applicants, so narrowing that down was somewhat difficult because so many of these were amazing people with amazing projects from spanning really anything you could possibly think of using a tool like this for. So our eventual winners hail from 24 different countries. We have at least one FieldKit 50 winner here with us this evening. We are in the process of still shipping out their stations because, surprise, surprise, international fulfillment during a pandemic is slightly difficult. But we really love to highlight these people because ultimately this is our mission, is to make FieldKit something that is representative of all kinds of people from all sorts of different places doing all kinds of different things. And last, we are in the process of putting together some working groups for shaping what FieldKit might look like for different types of demographics. So I currently have been specifically working with both librarians and educators to look at, what usage of FieldKit might look like, in their particular use cases. We're also looking to build them around citizen scientists and open hardware enthusiasts, but then of course also field scientists. So if you're interested in joining one of these working groups, we're going to put a link to a form in the chat that you can go and just say, hey, I'm interested in this, and we can get back to you about getting that together. We're always interested in hearing, what particular needs people might have. That's why we're doing this.
If I could interject one other thing before we go into the sensor roadmap. This didn't make it onto the slide for the working groups, but one of the things that we also are actively trying to develop here, and which we've been successful in developing so far for the sensors that we have available through the shop right now, is actually calibration protocols that will allow you to make your data actually traceable to some extent or another back to the National Institute of Standards and Technology here in the US, and all the way back up to the IPM in France, where the international standards actually live. The idea being that then your data is just as easy to compare with your own data as it is with anybody else's, by actually allowing us to grab some amount of traceability from these international standards through calibration. We assure that your data will be basically comparable to other data that's collected by other field kits throughout the world, and also that it's going to be future-proof against your own work. So just wanted to point out that since that's something we're still developing, that's kind of a subgroup of the working groups that we still want to get together, is people to try out our calibration protocols and make certain that we're moving in the right direction.
That's great, Pete. Thank you for pointing that out.
No problem.
You can, if you're interested in that, you can put it in the forum as well. We are multi-purposing. So here we have our current sensor roadmap. So in addition to the weather, distance, and 4 water sensors we currently have, these are some of the things that we are currently working on or envisioning. And one of the things that we're both gathering in our community forum, but also just in conversations with people during these sorts of events on social media, et cetera, is getting a sense for what sorts of things Are you looking to measure whether you have something to use for that or not now? And because we are a fully open source platform, even if we don't develop a certain sensor, we encourage and really want people to be building things on our platform, and we will do what we can to help facilitate that, because ultimately, you know, we're interested in open sensing, not just open sensing for FieldKit.
Yeah, and I'll kind of add on that. So the development pipeline that we have for FieldKit sensors is driven right now based off of projects that we have internally with partners. And so one thing that we're working really hard to get out is air quality sensors. There's a number of different sensor modules within that air quality situation, and soil moisture. Those are things that we've been working on. Right now, FieldKit has active partnerships and projects with the Wildlife Conservation Society and the Smithsonian and UCLA and some other organizations. All those projects are around development of new sensor modules and sensor module types. And one of those that we got funding for this year is to develop a marine version of FieldKit. And so that's a big development effort that we have ahead of us right now. But like some of those, like with one of our partners, Florida International University, is how do we create a module that can measure heat islands? And so one thing that I would say to anybody who's on this call, or anyone that you might know who's interested, we're always very, very interested in kind of finding new use cases for this. And it's a situation that, please, if you do have these ideas, no matter how crazy they are, please reach out to us, because we have some funding to do some development work, and since this stuff's all becoming open source anyways, we're happy to collaborate with anybody anywhere about these sorts of things. And one thing I do want to say is, you know, the configuration that you saw FieldKit in was this 4 module bay configuration, you know, but we do have like a version that's like a backpack version, so it's only if you want one sensor module, how do you make this run? And kind of as an extension of the things that we're doing around FieldKit Marine, we're thinking about, you know, smaller FieldKit modules and the other sorts of things that this would enable in research. And so just because you didn't see something today, don't think that it's not something that we're not actively thinking about or very interested in developing.
Awesome. Thanks, Shah. So to wrap things up, as you can see, we're a small but very enthusiastic team looking to build a very large and enthusiastic community. And if you're interested, we'd love for you to be a part of it. And that's what we've got for you today.
Yeah, I want to underline something Shah said about weird. You know, it's like we know that like sometimes it's really hard to find a solution for a particular use case, and that's what we're here for. And so if you have a particular use case that you think is not being like solved or served by the things you can buy, we want to talk to you. And if you are a community that maybe like doesn't have the resources that would be required to purchase the thing that exists right now, we want to talk to you. And you know, this is we are like a team, but this whole thing is an open source project, and the success of it relies on getting people involved in small ways and big ways. And we want to talk to you.
So we can leave this time open just to brainstorm about ideas or ask questions or whatever. Just feel free to unmute your mic and say something.
Yeah. Or type into the chat.
Yep.
I know some people are reticent to get on Zoom after a long day of Zoom.
I have a question. You had sort of mentioned that you can sort of have different data sets clustered together. I'm a professor, so I might use it in the context of students having different sets and then being able to like have a class together. But I'm also working on a project which is going to have like 4 different sites where we're planting trees. And one of the things we've been talking about is having environmental sensors set up at those locations. We're not quite sure what kind yet, but I could definitely see like the weather or air quality or soil. Like there's a lot of things that could go there. And so one thing I was wondering about is if I had like 4 stations set up, can they communicate with each other, or when you get those data sets, do you end up with 4 separate data sets, or like, can you merge them? Just wondering if you could talk a little bit more about what happens when you have multiple stations set up.
Yeah, that's a great question. And just in case there's something that sounds like a 5-year-old in the background, it's a 5-year-old in the background. So that, I'll try to be as succinct as I can, but there's like 2 ways you can organize like a group of FieldKit stations, and one of them is in a project. So in your example, you'd have these 4 stations that are all part of the same project, and so all the data from that project would be aggregated in the project itself. So when Shah was showing those ways of like comparing data, you could compare the data from one station and another. Like I could share a view of all the stations, all showing like soil moisture for the same week, right? So, and then the students might have a conversation around that. So that's sort of exactly the use case for what you're describing. And then the other one is collections. So collections allow you to do kind of the same thing, but with stations that you might not own. So the canonical example for us is like maybe the World Wetland Project. It's like every FieldKit station that's in a wetland, people could put together in a collection. But then on a smaller view, maybe it's like every FieldKit that's in a particular wildlife sanctuary could be built as a collection. So, and I think that's exciting too, because not everybody we know is going to be able to go deploy station, and especially in a teaching case, it's like, hey, maybe students can find some really good collections of things that show an interesting pattern. Maybe along a river watershed. Take the biggest river, the Mississippi, right? It's like do we see pattern as we kind of go down that river watershed? So those are possibilities as well. I hope that answers your question.
Yeah, perfect. Thank you. Mm-hmm.
If I may, I just wanted to expand on that a little bit on the pragmatic side, which is that insofar as collecting the data right now, unless you have Wi-Fi where the units are, you do have to go out to them and connect to the access point that the unit presents via your phone to download the data from the app. Or alternatively, you can also recover the SD card from the unit. But the thing is that because of that pragmatic side, that's also the reason why we're working on adding in LoRa capabilities. So we'll have long-range Wi-Fi that can, in theory, reach up to 14 kilometers out from the unit, and either have the units speak to one another insofar as a mesh network if they're close enough, or have a LoRaWAN gateway where you allow the data coming from each unit's LoRa transceiver to then get uploaded online, and then we intake that into the portal. So just wanted to give you an idea of how exactly that might look. LoRa is still kind of on the development horizon. We're nearly there, but Wi-Fi, that's easy right now.
Yeah, I wanted, just to add to the LoRa stuff. That is, we have a LoRa module for FieldKit. It's been deployed with one of our partners, but there's still a little bit of kind of software work that we want to do just to make that user interface very easy for people. So that's going to be released soon, very soon.
Cool, thanks.
I just wanted to ask about, I know that particularly Internet of Things, smart sensors, there's, the Internet Protocol IFTTT, which is, I don't know how long that's going to be around. Maybe there'll be something that comes along to replace it, but kind of bridging the gap between monitor and control. I know those are 2 pretty distinct things in this sensor space. So I don't know if you guys have any thoughts on that. Because essentially, like being able to trigger like a dehumidifier going off if relative humidity drops, goes above 70% or whatever, that kind of stuff.
I was talking about this with our software engineer, Jacob, earlier, and he was saying that he'd imagine that we'd want to use IFTTT or something like that, although I always keep calling it IFT. But the idea being that then you can control all the ESP32 linked smart outlets or whatever your particular switching modality is that you'd like to use. That being said, given the fact that our API and everything is completely open, there's also the possibility to link in with a normal webhook some other way and then drive something else. Like I could certainly see this driving like in orbit irrigation setup if you wanted to go that direction, or any of a number of different sorts of systems that use webhook APIs. So hope that clarifies a bit.
Yeah, and that's a great question, Bill. It's like right in our roadmap of what we're thinking about now. So like our focus for the last little while has been like getting the hardware robust and making sure that like the data lives there and you can get to it and it's telling what you need to do. But that's always been in our plans. So right now we're already starting to look at a sort of alerting system, so that will tell you things like, well, really practical things like your battery's getting low, but also to be able to set up things like, hey, tell me if this value goes over a certain level. So we would love to talk to you about like what your needs would be and how we could make that fit. Our kind of our short and long term path is always like, let's first try to make it sure that the data and the API are usable with existing solutions, and then kind of build in things that might be more useful. So yeah, we'd love to kind of figure out how we can make it work for your specific cases.
I actually had a question for folks, if you don't mind. So for some of the things that we're developing, it's a matter of how harsh of an environment we can develop for. And in fact, for some of our sensors, you can buy more robust versions of what we have right now. I know that in the past, I've worked with folks who were trying to put like temperature probes in eastern flow rivers that wind up in the Amazon on the east slope of the Andes, and they're dealing with rivers that are moving more than 3 meters per year in their bed, and they're only about a meter wide. So I'm just wondering, how many of you folks are in a situation where you think that what you see on our website right now might not be tough enough for what you're seeing in the field site? And is there any way that we can help you get towards what you need?
My name's Natalie. I'm interested in them for a few different projects. One of those projects is field work in the Solomon Islands. We have a couple issues there with access to weather stations and not being able to get close enough to them sometimes after they're deployed to get our data back. We also have some issues with theft of our weather stations, or what you might call cannibalization of them for various valued parts. So we need ways to secure our weather stations reasonably. We understand that the risk of theft is present in any field deployment that we have in some of the locales where we do field work, but I'm curious what kind of more rugged or theft deterrent solutions you might have, because the box looks pretty easy to break into.
Part of the development that we've been doing is honestly to make it so that the FieldKit unit itself, the boards, are, shall we say, enclosure agnostic. We can certainly put that into something else. And speaking back beyond my my start with Conservify and FieldKit, when I was a grad student, we used to put some of our water level gauges in telephone network interface boxes because they were completely invisible to everybody. They were just so common all over the place that people would see one and it wouldn't register as something that you'd ever want to screw with. That being said, once you put a solar panel by it, you're drawing attention to it. But there are certainly plenty of ways to camouflage this sort of thing. Another method that I've actually seen done by my advisor in grad school, he managed to get himself an extremely accurate rain gauge that basically looked like a length of PVC pipe, and decided to put it out and have it logging rainfall for a while. And he decided, you know what, I want people to avoid this, so I'm going to paint it blaze orange. That was a mistake. He found it blasted to smithereens by buckshot. And so afterwards, he bought another one. And what he did this time was he also bought a piece of PVC pipe that was the same length and same diameter. Painted that blaze orange, painted the other one camouflage green pattern, and put it about maybe 10 feet, put the orange one 10 feet away from the actual sampling site. And when you know it, that one got blown to smithereens and the camouflage one was perfectly fine. So distraction or security through obscurity is certainly an option.
Yep. Yeah, gotcha.
I just posted a link for Nancy, who is working in more urban spaces. One of my friends has that awesome tactic of using rat bait boxes for this stuff, because literally nobody will ever touch it. It's an excellent plan. But so you know, we have battery that can be swapped out. Certainly solar again would be an issue, but I still think even a solar panel connected to a rat bait box would make people not want to touch it. But yeah, Natalie, those were great questions, and these are the kinds of things that I think there's a lot of like shared knowledge around, but that's one of the things we're trying to do with our community station, because I don't think there's not a straight up answer to any. It's very case specific, but I think that's the kind of knowledge we would love to be able to give to people. Like, hey, here's some ideas. Let's figure out how it works in our particular environments. So we'd love to pick your brain about that.
Perfect. We'd love to be part of it. Whatever community of practice around different kinds of field stations and ways to keep the data flowing. We're all about that.
Yeah, we actually just got some pictures back from one of our latest deployments in Cameroon that are exactly as you described there, like completely torn apart. So we're you know, in that case, it's like, can we do two things? Can we like do a better job of making it maybe a little harder to get into, but also doing just a little bit better job of how we're communicating what we're doing and working with community groups, which is a huge part of what we're trying to do. And that to me is like the two tactics you have to do at the same time.
Totally.
I would also add that, you know, one of the things that we're trying to do with like the knowledge management side of FieldKit not only is like, oh, this is how you set up a FieldKit, but also what are some best practices that we've learned around things like pH sensors or weather stations, and then also like what are things that we've learned or, you know, friends of ours have learned from deployments and better ways to put things in places or hide things, or, you know, make sure that it not only, you know, it protects it from human impact, but also interactions with animals and allows you to get the best data and all that sort of stuff. So all that kind of content we're starting to like put together right now for the website. But like if you were to go to our community forums and stuff, like we're going to be posting about a lot of that there.
Yeah, that's thanks for mentioning that, Shot. Yeah, that's sort of community of practice knowledge sharing. That's really what makes, you know, a forum like ours something that's really powerful. Like down the line is that there's a lot of things that I can't answer that somebody who has experiences that none of us have ever had that could answer. And so we really believe that there's a wisdom in the community. And I am absolutely going to steal that question as a prompt for the community, because I think it's a really good one. And just with the rat bait boxes also has some potential for some hilarity as well.
Also, insofar as animal involvement, I will tell you that I've got a lot more experience than I'd like to have with regards to everybody from chimps beating the heck out of acoustic recorders I've built with sticks and stones, literally. And well, we did get the recording back at least, but up to cows flossing their teeth with my cables, which is one of my favorites to tell. Yeah, don't trust cows. But the idea of being able to harden and do it for a small enough price, that's going to be useful for everybody who's also using the more expensive, in our opinion, soon to be outmoded stations. But we want to bring everybody on board to try and get those ideas out in the open and figure out how we can avoid these problems. Not just humans messing with things, but other animals. Biofouling as well is always going to be an issue, especially for water sensors. And we have some suggestions already in the forum about that, and some of them have even made their way into our product guide. Like, for example, we do recommend the use of cable wraps or cable armor to protect the cables running into the box itself. And that's not usually something that you see on like an on-set hobo station or something sitting out in the middle of a park. So.
Hey guys, I have a question for you. I am Felix. I am based in southern Brazil, and I'm wondering if your platform, how it's gonna work with, let's say, I don't know, legacy sensors or sensors they are laying around, and I want to integrate them into your platform. For example, there are a bunch of, light sensors from Lycor, or let's say a Campbell scientific sensor. So I'm gonna be able to integrate those sensors into the platform?
To put it simply, yes. But the thing is that there may be some sort of interstitial stage. Like, for example, I'm currently working on a module right here that allows us to break out the I2C bus from our microcontroller, basically allowing us digital communication, and putting onto that an analog to digital converter with a current mode amplifier allows you to interface with a Lycor unit. We're not quite there yet. We don't have the full module made up, but that's certainly something that we're looking at doing in the near future. On top of that, luckily there have been enough people who have reverse engineered the protocols that Campbell and Davis and all of the others use that allow the serial communications we can do, like 3-wire for the older Decagon soil moisture sensors. That's a serial protocol that's based on RS-485 that we might be able to work into this. But the beauty of us having an open source design is the fact that we can work with you on this, but you can also, based on whatever your knowledge level is, work on it yourself based on the work that we have, because we're a 10-person team right now, and we can't have every iron in the fire, but we can certainly also consult and help you through the forum. There's a lot of, like Lindsay was saying before, out of our working groups, one of them is going to be open source hardware and software people, and getting together with them and with us is going to enable you to move forward on that. So simple answer, not yet, but we're getting there.
Got it. Thanks.
Yeah, I mean, I would also add, since it is an open, FieldKit is an open source project, like typically the limitation with respect to integrating other sensors is going to be in how much the public knows about the proprietary systems out there that you would like to, integrate into. And so in the situations like Pete mentioned, if there have been people who have kind of reversed engineered how to work into these things, then we can interface quite well with it. If not, then it's going to get a little bit more complicated. And then the last thing I would say is there are open source projects out there, things like AudioMoth, that we are close colleagues with, and we will figure out ways to interface between FieldKit and AudioMoth quite well, because we're both open systems talking to open systems, right? And so that's kind of the limiting factor with a lot of that stuff.
And I mean, would it be fair to say too that, like, if Felix, if you went through the work of figuring out how to get your old Campbell scientific sensors to be working with a FieldKit, that would be something that would be so valuable to share on the forum, because you're probably not the only one trying to solve for that. And, whether you're out there exchanging ideas of what worked or didn't work for you, or you're getting it from someone else on the community, I feel like that's kind of exactly what we're hoping to see there.
All right.
Yeah, if anybody has any other questions, I posted my email in there before. And then I'm actually the exception to the rule. Everybody else on the team is at conservify.org. So Shah at conservify.org, Pete, Lindsay, Ali, so any of us. And then we also have a catch-all email, everyone at conservify.org. So like, or at fieldkit.org. So please get in touch. We're always happy to hear anything you have to say, as long as it's not mean.
Yeah, please reach out.
Yeah.
But thank you.
Yeah. Yeah. We hope that this is, you know, the beginning of a relationship between a lot of us. So please don't ever hesitate to drop any of us a line. And, you know, I'd love to see some of you in the forum, checking stuff out in the portal, wherever. We'd love to have you involved. All right. Well, have a great rest of your day or evening, everyone.
Thanks
And
a lot.
Thanks, everybody.
Kat, this is wonderful.
Care.
Thank you.
Thank you.
Yeah, thanks a lot.